Welcome everyone to the webinar today. Thank you so much for joining us. My name is Lauren, and let's go ahead and get started. Today we're going to talk about safety culture, what safety culture looks like, how it can affect your SIFs, and the Site Safety Index. As I said, my name is Lauren Stewart. I am a CFSE and I work here at Exida. I work mostly with our mechanical customers. I also go and teach courses and speak at conferences and do the booths at different conferences and shows. If you are new to these webinars and might not know who Expa is, I like to say no matter where you are or where your products were certified or where your customers are, whoever you may be, we have someone close by. And we deal with everything to do with functional safety, be it functional safety itself, alarm management, or cybersecurity. We are involved in the complete supply chain of functional safety. So if you're an OEM, we help certify your products. We have tools for you. If you're an end user, you're putting to use those certified products. We have consulting and tools for you as well. We have the people in the industry, personnel certification, all of the whole way through. As long as it has to deal with functional safety, we have someone that can help you. As I mentioned quickly, we have engineering consulting services, not only just in functional safety or process safety, but also in alarm management and cybersecurity. For each portion of functional safety industry that we are in, we have a tool, and those tools are really designed by the people here at Exida to help save time and save you money. So it increases your efficiency and your productivity, whether it has to deal with PHAs, SIL verifications, SRS improved test development, alarm rationalization, cyber risk assessment. We have tools to make your job easier and your life easier. That's what we want to do for you. We also have certification. If you are an end user using products, this is what your products did to become certified. We also have certification in ISA Secure, tool qualification, machine safety, and personnel programs. But enough of who Exida is. Let's go ahead and get started with the webinar itself, because that's why you're really here, right? So today we're really going to talk about safety culture, what it means, how it's defined, and some ways to address safety culture. Where this all began was we were looking through numerous field failure studies, and we were comparing them and noticed that devices, specific devices, be it the same manufacturer and even same model number, were having different failures from one site to compare to the next. Say company A had some, while company B, the exact same device, same application, were having way more. So we wanted to dive in and take a look at it. And we noticed that it wasn't just that one device, it was a multiple. So we started researching and diving in, and we were able to figure out that failure rates are really compiled upon product specific, but then also site specific. So you could split failures between product and the site. And if you just look at site specific failures, same product, same model, same manufacturer, different site, differences could be 1.2 to almost 2 times in One case we saw 3 times, based from site to site. So Exida created what is called the Site Safety Index based on all of the requirements from IEC 61508 and 511 to encompass safety culture. And that Site Safety Index is how you can make up for the differences from site to site. And that's really what this webinar is going to dive into, that Site Safety Index. And you might hear me refer to it as SSI from time to time. Just so you know, Site Safety Index and SSI are one and the same. We really want to look at how site-specific activities could affect random failure rates, PFD calculations, life cycle costs, and where all of this information comes from and where it's captured. So to break it off into 4 main topics, we're going to start looking at what Site Safety Index is and how it can affect random failure rates. Then we're going to look at how those random failure rates affect PFD average calculations, what the differences between PFD average calculations are and realistic PFD average calculations. Then we are going to move on to safety culture and how it can affect life cycle costs, and then where to find this information. So let's start off with just what is safety culture. And as I mentioned already, Site Safety Index, or we thought of Site Safety Index because of a study, and actually numerous field failure studies, showing that things were happening differently from site to site. Why is this happening? Why are the failure rates coming back different? So we started doing some site audits to figure things out. And we noticed that there were specific things that differ between one site to the next. And those differences were impacting the safety instrumented systems. And you might be sitting there wondering, well, why is she saying site often and not like company safety index? Well, we actually found when we were exploring that it's not just company to company, it is actually site to site. There have been times where same company, same parent company, same overall global procedures, drastically different practices and different failures. So the Site Safety Index will cover all of the variables that can be collected underneath what is safety culture. Safety culture is really the part to play where humans are involved. Safety culture can be an imperfect repair or calibration. It wasn't set up the correct way. All of those things are affected because of humans. I know I am not perfect, and as long as you have humans working in your plant, you're not going to be perfect either. And the more humans do, the more chances that there can be mistakes brought along. Let's think, how many of us today have made typos? I know I've made plenty. My spelling is out. It's just plain awful. So I've deleted multiple sentences. But what about even more? Have you done something when you were getting ready this morning? Were you not paying attention and knocked something over? Humans are not perfect. And as long as you have humans working for you, well, hopefully your employees are not going to be doing the things in these pictures, but you get the idea. things happen. When humans are involved, they especially happen. But the point is, as long as you have an appropriate safety culture, you can lessen the effects of these, or lessen the amount of these accidents happen. But if you do not have a proper safety culture, no matter how great your calculations were, no matter if you bought the best, most expensive equipment possible and put it together perfectly, if the safety culture at the plant isn't maintenance or forward, or it's not very good at testing or pushes it out, safety culture can completely cancel out all of the good you did with your calculations, the good you did buying certified products. All of that won't matter because of poor safety culture. Because of this, the Site Safety Index was created, and it was created from all of the concepts based in IEC 61508 and 511. And from there, we put together an index for you to be able to either self or by third party evaluate and see how you are doing. And as I said, as long as humans are involved, the Site Safety Index should also be involved. When you are doing all of your calculations in functional safety, there's an assumption that human factors do not play a part in the safety system's performance. So that all of your calculations did not include that human factor error. So the Site Safety Index allows you to take a more realistic approach and look at what human factors will actually play. But the second thing, it also, say you have that company that one type, Site A is doing very great and Site B is doing not so great. You do not want to be punished for your sister company's neglect. So Site Safety Index actually allows you to lower your failure rates because of the great things you're doing, while not masking your sister company for doing the same thing. As I said earlier, there are two ways you can evaluate Site Safety Index. First, you can have the kind of non-biased approach, an external audit come in, and someone like Exida can come in and walk through, ask a bunch of questions, observe things, and give you, like I said, a non-biased opinion. That third-party opinion, which is always a wonderful thing to have. Or you can go through a questionnaire and give yourself a kind of audit and see where you think you fall. There's a Site Safety Index has a website that you can get the questions if you want to do it yourself. These are just a couple sample questions, such as, are you scheduled? Proof tests perform on schedule? Do you have perform periodic proof tests using written procedures? Do you pull equipment before the end of useful life? That type of questions. So you can then see about where you fall, or where you believe you fall, compared to others. The Site Safety Index model is set up kind of like your safety integrity level model. You have Site Safety Index 0 through 4, just like your safety integrity level, or the SIL 0 through 4. SIL's 0 or site safety index 0 is there's nothing, right? So in site safety index, that nothing means you don't do repairs, you don't do testing, you keep the equipment in. When it finally ends up failing, you pull it out of service, and that's that. But on the other extreme end, you have SIL 4, or Site Safety Index Level 4. That absolutely perfect. Repairs are always done on time and correctly. Testing is always done on time and correctly. And you always pull everything before you have any inclination that it needs to be done. Something just like your SIL 4, your safe or site safe index is kind of unheard of. It's mythical. It's that unicorn. People have heard of it, but have you really met anyone that has seen one? Typically, we will assume that people fall under site safety index level of 2. You do most of the repairs and testing on time. You do it as correct as you can, but nobody's perfect. And sometimes if you're doing a lot for functional safety, you might be an SSI 3. So I've talked about the different SSIs levels. Who cares? Well, it can specifically impact your functional safety. I did a quick SIF in Excellentia. This is part of the module if you've never seen Excellentia before. I just did a sensor, a logic solver, and a final element, 1 out of 1 final elements, and ran my calculations and found that for this simple SIF, I was able to achieve a safety integrity level of SIL 2 and have a risk reduction factor of 113. And this is all assuming perfect maintenance, 100% perfect SSI 4. I then did the exact same analysis, but this time I said that I am pretty dang good. But I'm not perfect, but I'm doing almost everything perfect. So this isn't even an SSI 2 or an average or typical. This is SSI 3 superior. You have now only achieved a risk reduction factor of 98, which that's not too big of a difference, but your achieved safety integrity level is only SIL 1. And if you've done all of your safety calculations, assuming SSI 4, when you are indeed not, you could be assuming that you're running at a SIL 2 level. Well, actually, you are only achieving a SIL 1 in protection. So why is this? Well, a key metric in the process industry and all the design is PFDAVG. I'm sure if you are involved in any functional safety, you've heard of PFDAVG probably before. And I said before, we did several studies on many different field failure results, more proof test reports, and we noticed there are several variables that have been identified to make that PDF calculation realistic. So you could just use your 100% simplified equations, or you can actually take into consideration 9 key variables in PFDAVG. And as you can see, number 8 is the Site Safety Index practice. Now let's take a look at how many of the 9 key variables are actually affected by site practices. Well, 7 of the 9. This would be the failure rate, the proof test interval, the proof test effectiveness, the mean time to restore, and the probability of initial failure. So the site safety index, as I said earlier, it's going to be your difference between your targets, or that unicorn, or what you were hoping to achieve, and the reality of life. So we're going to go through, oh, that's next. Sorry about that. So why is this important? Who cares? Well, the PFD average calculations are, as we just talked about, impacted by those site operational practices. And we can actually model and show impact of your site practices on your PFD average. Taking that, it could affect your safety integrity level and your risk reduction factor. So you can actually model life cycle cost comparisons if you're going to be perfect in maintenance, if you're going to be really, really great at maintenance, if you're going to be average, poor, or none. And you can put cost to justify increasing your maintenance and actually show it through functional safety, which is pretty cool. The things that affect your site safety index can include commissioning testing, safety validation tests, decommissioning and modification procedures, repair procedures. So keeping in mind that list, we're going to look at how those key variables impacted by site practices. And remember the first 5 from the PFD average calculation. You have your failure rates, proof test, interval and effectiveness, mean time to restoration, and probability of initial failure. We're going to look at each of them in depth a little bit more. So the first one is failure rates. As you drop site safety index levels, so as your maintenance gets poorer and poorer, your failure rates are going to increase. Why is that? Well, your failure rates come from an FMEDA, and your FMEDA makes certain assumptions that you're actually doing the things you say you're going to do. The products are installed in the environment that's supposed to be, with materials compatible, commissioned and calibrated per the manufacturer's instructions, and so on. So if you're not doing the things that the FMEDA assumes that most practices are, you're actually going to have higher failure rates. The next is proof test intervals. And as you go lower and lower through SSI, so as your maintenance gets worse, your proof test interval are increased in those lower SSI levels. In a survey that we did, it's apparent that proof tests are postponed more often when a higher level of discipline is not present. So as you get lower in those SSI levels, and you maybe don't have your company wide parent procedures, maybe one area is more a little lax from site to site. So as you decrease your site safety index level, your proof test intervals end up increasing. While the opposite is true with effectiveness. Proof test effectiveness decreases when procedures aren't clear or when test personnel don't have the time to perform the testing or to document the testing. Next is mean time to restoration. Well, the mean time to restoration is going to increase when diagnostic procedures are either not well documented or not well understood. The mean time to restore will increase when there's not tools ready, when people don't know what to expect, and some actually restore efforts will not be successful when personnel don't have the time to perform the results. And then sometimes a second effort is then needed. And then finally we have probability of initial failure. And as you decrease in SSI levels, your probability of initial failure is increased. So products used in the safety function may not operate properly if they haven't been properly installed, or maybe not calibrated, or not tested after commissioning. So when procedures are not clear and there's just no time available, the probability of initial failure is going to increase. So where does this come about? Well, as I told you, you can get information about especially failure rates in the FMEDA analysis. And in this Appendix E, there's all about the Site Safety Index, and there's two new tables. So firstly, you have this is an example, table 9. And in the regular FMEDA report, you're going to have SSI level 2, your typical or average. Then in the back of the FMEDA report, it's going to give tables for SSI 4. So you did do the questionnaire or had a third party come out, and they let you know that you are actually at a higher safety culture level or higher maintenance. This will give you tables in static, and then also the next table in dynamic operation, assuming SSI 4. And those failure rates, the ones that have, those will be usually lower, depending on what parts are in the FMEDA, of course, but those usually will be a lower failure rate. So, wrapping things up, the Site Safety Index lets you be more realistic when you're doing your PFDAVG calculations. It allows you to take, if you're doing a really good job, take credit for that while not covering up your sister company's errors. And we talked briefly about how you can justify improved operational processes through monetary, show that being a little bit better could save you money. If you want more information on all of these, we have 3 white papers on our website. Go on exida.com and go under our resources tab. And then finally, I'm going to go ahead and take some questions. And we don't have any questions at this time, but if you want more information or training in functional safety, please feel free to go on our training website. And thank you all for joining us today.